Hey everybody, welcome back. We are on the second to last lesson of the chapter. Today we're doing 151 to 158. Homework is 162 to 168. And problems 151 and 152 will be done on this resource page. If you do not have the ability to print this resource page, no big deal. Just make this table, and this guy, you don't have to make these shapes, just put the numbers. But do try to line them up like this. Okay, so for problem 151, it says, work with your team to complete a table for combinations like this one below, or using the student e-tool. Okay, so what this is saying is go to math, probability, NCR, and it's telling you N is the number on this side and R is the number on the top. So for this box right here, it would be 0, C0, which is 1. Okay, now let's try this box and see what happens. 0, C1, and that's 0. Anytime that there's 0, we are going to leave it blank because that can't actually happen. The number on the left side is the total, and the number on the right side is how many you're taking out of it. So I can't have a total of 0 and take 1 out of it. So as you can see, the rest of these are also going to be 0, so we're just going to leave that row alone. Okay, so now we're going to do this one. This first box here where I'm pointing is 1C0. So notice the 1 is coming from here, the 0 is coming from there, and that should be 1. Okay. Next one is 1C1. 1. Okay. And then this box, 1C2. Okay, that's 0. Hopefully you're thinking, oh, well, that can't work because you can't have a total of 1 and take out 2. Okay, so what you'll notice is that we will fill in one more in each row as we go. The rest of this will remain blank. So for this, you have 2C0, 2C1, and 2C2. And that's as far as you can get there. Okay, because 2C3 won't exist. 3C0, 3C1, 3C2. Okay, but we can do 3C3. Which is 1. Okay, hopefully you're noticing some pattern here in the table we're making. So 4C0, can you guess what it is from all of the previous entries here? Yep, it's 1. Okay, let's try 4C1. Four. Okay, do you notice that these numbers all match N? So 1, 2, 3, 4. Okay, 6, let's just check it. Yep. And that makes sense because that's the problem we did before with, oh, I can't remember her name, but the girl that was playing softball and she had 2 hits out of 4 at-bats. So 4 at-bats, 2 hits. There were 6 different combinations that had 2 hits in them. Okay, 4C3 is 4. Okay, and then notice on the diagonal here, this is 1. Okay, so let's see if we can not use the calculator to go a little faster and see if we can fill these in. So I know this first one's going to be 1. I know this second one is going to be 5. This one I'm not sure, so I'm going to do 5C2. 10. Interesting. Okay, I know this one's going to be 1, and then what I'm hoping you see here is that these are symmetric, so they go forwards and then backwards. If there's an even number of them, that middle number repeats. If there's an odd number, it just starts to go backwards. So this one's 1, 5, 10, 10, 5, 1. So notice I got that down to one calculation. Okay, 1, 6. Okay, 1, 6. I don't know what these are. Okay, so 6 C2 is 15. Okay, because of symmetry, I know that this will also be 15. 6C3, 20. Maybe in this row, some people are shouting out +2, +3, +4, +5. I don't know. Maybe they are. Okay, row 7. 1, 7, 1, 7. Okay, +2, +3, +4, +5, +6. We better check it. I'm writing in pen. Yep. Okay. Okay, and because of symmetry, I know that will also be 35. You having fun yet? 1, 8, 8, 1. Okay, +2, +3, +4, +5, +6, +7, 28. Anyone figure out a pattern for this? +3, +6, +10. Oh, it's adding this. +3, +6, +10, +15, +21. Let's check. Yep. And this is going +4, +10, +20. Oh, this is oh. Oh. How fun. Okay. Table is done. This is number 151. And then for number 152, you really don't ever see this. This table is very important. It's called Pascal's triangle, but you don't ever see it written this way. This is really nice because it helps you see patterns and addition and using your calculator to really figure out what you're doing with the NCR. However, this is usually the format you see. This is called Pascal's triangle. So for number 152, all we're going to do is take these numbers and put them here. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. Okay, and we did not put the 8th row in here. That's okay. This top one doesn't really get used. This is called row 0, row 1, row 2, row 3, you need to label these, row 4, row 5, row 6, row 7. Okay, so there's a couple of things. First, the row number is determined by the first number in that's not a 1, so 2, 3, 4, 5, 6, 7. Row 1 only has 1s. Row 0 is the top. This will be important in a moment. Okay, now let's just say that you need to do something with Pascal's triangle, but you don't have it on you. That's okay, it's easily recreated. What I want you to notice is super cool pattern that this number plus the number next to it always equals the number right underneath. So 1 plus 2 is 3, 6 plus 4 is 10, 5 plus 10 is 15, 15 plus 20 is 35. You can always recreate Pascal's triangle easily as long as you remember to start with a 1, 1, 1, and then just this side is always a 1, this side is always a 1, and then just add the 2 to get the middle, 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 add the 2 to get the middle. Okay, so that's 151 and 152. Now we're going to go to 153. Oh, one more thing. On this side of your resource page, you have different Pascal's triangles in different ways. You might see them on the internet if you were to Google Pascal's triangle. We wanted to give you as many representations as we could. So here's your Pascal's triangle with boxes. Here's your Pascal triangle with exponents. Here's unexpanded form and expanded form. This is a little bit of a spoiler alert, so I'm going to skip that. And then this is the one we use in AP Statistics. This is 3C0, 2C0, 1C0. It's just written in statistics notation. Those are all equivalent to this guy that you wrote on the front. Okay, so 153. Okay, so he is going to ask us to write a plus b squared in expanded form. In other words, multiply a plus b, and combine like terms. Okay, so we're back to math 1 here a little bit. Okay, so a plus b squared is a plus b, and I'm going to make a box for that. Okay, a squared, a b, b squared. Okay, and the answer is, combine those, a squared plus 2ab plus b squared. Okay, you guys are like, what the heck does this have to do with anything? Well, the Pascal's triangle that we just created is useful for binomial expansion. So this is a binomial, and it means expand it by multiplication if you are too lazy, like I am, to do the box. Okay, what I'm going to do, the goal of this lesson is to show you how to do this, bypassing all of this and just get to here using Pascal's triangle. Okay, what I want you to notice is this is 1a squared plus 2ab plus 1b squared. I want you to look at those numbers. 1, 2, 1. Those leading coefficients occur here on row 2. 1, 2, 1. And if you remember, on this Pascal's triangle, it said exponent 2 was 1, 2, 1. We call it row 2. The 2 here matches the exponent of 2. So I'm going to come back in and circle this. row 2, because that's a 2, gives us 1, 2, 1. Okay, later on I will teach you how to figure out the letters. Okay, b, a plus b cubed. So I'm going to do this box style one time so that you can see I'm not making stuff up with Pascal's triangle. You can see it works. Okay, so for this one, what I'm going to do is cheat a little bit, and the first two here, I would do a box for that, but that would be this box here, and I would get this answer. So from the previous problem, these two multiplied would be a squared plus 2ab plus b squared, and I need to multiply that by another a plus b, which is a 6 box. Okay, so I have a to the third plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. Okay. That equals a to the third plus 3a squared b plus 3ab squared plus b to the third. Okay, so now we need to see if our theory about Pascal's triangle works. 1a to the third plus 3a squared b plus 3ab squared plus 1b to the third, 1, 3, 3, 1. Okay, so let's go look at row 3. Row 3, 1, 3, 3, 1. Okay, hopefully some of you are getting the chills. I'm kind of joking. Okay, so what we're going to do is so we're going to go to C here, but I want you guys to see something interesting about this. For C, it says, how many terms do you think a plus b to the fourth will have when written in expanded form? Okay, so we're not going to do the whole problem. What we're going to do is figure out how many terms there will be and what will the leading coefficients be in that problem. Okay, so we are going to do fourth exponent. Notice that the one with the square, the 2 exponent, came out with 3 terms. The one with the third exponent, the cubed, came out with 4 terms. So how many is going to come out of the fourth exponent? 5 terms. And it's exponent plus 1. Okay, and what will those leading coefficients be? Okay, so this is telling me I am in row 4 because of the 4 exponent. Okay, row 4, 1, 4, 6, 4, 1. Okay, last problem, we're going to do a plus b to the 6th, and we're going to do a plus b to the 6th without using the box. So we're going to use Pascal's triangle. Okay, the 6th is telling me that I'm in the 6th row. Okay, so the first thing I'm going to do is write down my leading coefficients here from the 6th row. 1, 6, 15, 20, 15, 6, 1. Okay, that gives me 1, 2, 3, 4, 5, 6, 7 numbers, which makes sense. There should be 7 terms if we are the 6th power. Okay, now, how do I get the letters? Okay, what I want you to notice is that these two problems, the A was to the power circled in pink. Okay, so this is how it goes. Okay, so the thing in front is going to get the full power, and the thing in the back is going to be 0 power. And then as we move down the line, the one in the front is going to go down a power each time, and the one in the back is going to go up a power each time. Okay, so plus 6. Got the 6 from right here, so 1, 6. Okay, the A is going to go down a power, the B is going to go up a power. Plus 15. A is going to go down a power, B is going to go up a power. A down a power, B up a power. A down a power, B up a power. A down a power, B up a power. Oh man. A down a power, B up a power. Okay, and then we're just going to make this look a little nicer. We're going to take the 1 coefficient out, and the B to the 0 and the A to the 0, we're going to make those 1s. And anything to the 1 power, we're just going to write the letter. So this combined is A to the 6th plus 6A to the 5th B. Don't write the first part. You can, but I'm trying to make this prettier. Plus 15A to the 4th B squared plus 20 A to the 3rd B to the 3rd plus 15A squared B to the 4th plus 6A B to the 5th plus, and then that's 1 and that's 1 and that's just B to the 6th. Okay. Okay, so 154 is kind of a question that is asking a big question, and 155 is kind of the answer to that question. Okay, so for 154 it says, you notice the patterns. Patterns are powerful tools. Why are the numbers in Pascal's triangle the same as the coefficients in the terms of the expanded form? Okay. Well, to do this problem, we are going to do 155 with it. 155 is a further guidance problem for 154, so it kind of leads us through it step by step. Okay, what I want to do is figure out kind of where these things are coming from, and what I want you to notice is that I referred back to the previous lesson. This 6 is very important because that is from the previous lesson where we had the girl was doing her at-bats, and she had 4 at-bats and 2 hits, and there were 6 listed out that had 2 hits in them. So what this is doing is this is taking away the need for a huge tree diagram to tell you exactly how many of these there would be. So if I did a tree diagram, there would be 1 of these, 2 of these, and 1 of these. And tree diagram, 1 of these, 3 of these, 3 of these, and 1 of these. So what we're saying is we can use the combinations to figure out the leading coefficients instead of Pascal's triangle. So what I want to do for this is a plus b to the fifth. Okay, so we're going to do the same thing, but instead of using Pascal's triangle, we are going to use the combinations. So if you remember, how did we find these numbers? We found this one by 5C0, 5C1. Notice we would be in row 5. I'm just going to make a note, row 5. Okay, so this number is 5C0, this number is 5C1, 5C2. So instead of just saying, if I don't have Pascal's triangle on me, I can do it this way. Okay, so 5C0 would be the first one. And I'm going to take my idea from this problem. So the variable, letter, number, whatever's in front in the parentheses would get the full power that you're working with. And then whatever is in the back of the parentheses would be 0. Okay. Now we're going to take this one up. So notice the next one in the box here, this was 5C1. And then you guys will start to see the pattern. 5C1, okay. Then I'm going to take this same idea, take this down a power, and move that up a power. The worst thing about these problems is they are long to write. Some of my students turn their notebooks sideways for this lesson, but I just can't seem to adapt to that. Okay, how is this helpful? Well, it's great for several reasons. First, if you don't have your Pascal's triangle on you, you can always find the leading coefficients using combinations. It's also really helpful for our problem number like number 156, where we only need to find one of them out of all of them. So you'll notice in 156, it's going to ask us just to find one of these and not all of them. Okay, so 5C0, I already know from my table, so I'm going back to my table here. 5C0 is 1. So 1, a to the fifth, b to the 0 plus 5C1. 5C1 is 5. You might be asking yourself, why is she doing this when it's the same thing as Pascal's triangle? It is. I'm just showing you that there's two different ways. This one kind of requires you to have the triangle on hand. This one you can use your calculator to find the leading coefficients if you don't have the triangle. So these are the same thing. 5C2 was 10. 5C3 was also 10. And remember, the symmetry will help you speed this up. Okay, and then I'm just going to clean it up. Anything with a 0 power is going to become 1. Anything with a 1 is kind of going to go away, and then the 1 exponents will go away. So a to the fifth plus make sure you guys can see this. Yes. Okay, great. So, exactly the same thing, two different methods. This one, the numbers were taken from Pascal's triangle, row 6. This one, we did not have the triangle. That's okay. We used combinations on our calculator to find the numbers of the leading coefficients. Okay, 156. So 156 is interesting. It says we have a plus b to the 9th. Don't worry, everyone. You're like, no, she's not going to make us do it. No, okay. So for his homework assignment, Andrew has to expand a plus b to the 9th. He does not know the coefficient for the term a cubed b6. He starts by writing out the first 9 rows of Pascal's triangle when his friend Robbie says, just use combinations. What combination should Andrew use, and what is the coefficient of the a cubed b6 term? Okay. So we have a bunch of things, plus we have this term here, which is going to have an a cubed b6 on it, plus, and then we have some more things here. Okay, notice we don't need to do the whole problem. All we're trying to figure out is which one of the combinations would go here and what that would be in the end. Okay, so notice that back in this problem we started with 5C0. Okay, and this number here, the r, so this is NCR, matches the exponent of the second item. So if you guys want, I could get my pink pen out. This matches that. This matches that. Okay, so I'm going to come back over here. Whatever this is will need to match that. So I will have 9, because 9 is the total, C6. Okay, where does this 9 come from? That comes from there, the total. 6 comes from needing to match the exponent on that second item. Okay, so 9C6 is 84. So I have 84, a to the 3rd, b to the 6th. Now, if I just hate this so much that I really want to write out Pascal's triangle to 9 rows and figure out what the 6th number in would be, actually it would be the 7th number in, because you have to start with 0. You could find it that way, but see how combinations help when you're down to a really far set of rows in Pascal's triangle. You don't want to draw it out that far. Okay, 157. Sorry about that, that was my dog. She was taking a nap. Okay, Rebecca needs to write the 5th term in the expansion of a plus b to the 11th. Okay, so notice the book is getting us kind of exponents that are pretty far down there so that we don't want to use Pascal's triangle. Okay, so we have a plus b to the 11th. We want to find the 5th term. So we know we're going to have some stuff, and then we're going to have the 5th term, and then we're going to have some more stuff. Okay, how can I figure out what letters and what coefficient will go for the 5th term? Okay, so let's go back to our completed ones. What do you notice about the exponent of a in this problem that is 5 terms out? So 1, 2, 3, 4, 5. The exponent of a is 1. Okay. So what I sort of need to do is count down. I have 11, 10, 9, 8, 7. Okay, so the 5th term will be 7. Let me do that again. So a to the 11th will be the 1st term, a to the 10th, a to the 9th, a to the 8th, a to the 7th will be the 5th term. One of the ways that you can find that is you can take the exponent minus whatever term you want it to be, that's 6, and then you've got to add 1 to incorporate that 0 being in the front, so that's 7. You can take the exponent minus which term that you're looking for, and then you have to add 1 to kind of take the place of that 0, 1 in the front. Okay, so I have 7, which means that I'm going to have a to the 7. Okay, I am 1/3 of the way there. Now I need to know how many b's there will be. Okay, what I want you to notice is each of these terms, the letters, the exponents will add up to the total exponent here. So I have a to the 3rd, b to the 6th, 3 plus 6 is 9. Okay, 7 plus what is 11? 4. Okay, make yourself a little note. Add to 11. Okay, now I'm going to use my trick from the previous problem. I know that is 4, so my combination on the front will need to be 11C4. 11 being the total, and combination 4 because that number needs to match the second exponent. Okay, 11C4 is 330. A to the 7th, b to the 4th. And there will be things on either side, but this is the 5th term. Okay, that's actually A. B says we're going to take this knowledge and we're going to find the 5th term of x minus 2 to the 11th. Okay, so this is very important that we kind of follow these same patterns. It doesn't matter what these things are in the front, we're just going to replace them. So I want you guys to see that this is exactly the same, and it will give us a good opportunity to review what we just did in case anyone found A to be really challenging. Okay, so I'm going to pretend I have a new problem. I know I have some terms in front. I'm going to do the 5th term here, and then I have some terms after. My first step is going to be finding the exponent of the first item. So in this case, I found the exponent on the A. In this problem, I'm going to find the exponent on the X. So I have 11 as my exponent, minus 5 equals 6, and then I'm going to do the same calculation, plus 1 to count for that 0, equals 7. Okay, so I want you to see I have x to the 7. Okay, did anything really change? The only thing that changed was I had a to the 7th, and because my x is in front, I now have x to the 7th. Okay, step 2 is to take whatever the second thing is and make its exponent add to the total of 11. So the second thing in my parentheses is -2. Make sure that you count that as -2 to the 4th power. So I have the first thing to the 7th from this. Then the second thing, -2, has to be to the 4th because those need to add to the total of 11. And then my combination in the front is going to be the same because the exponent here, the second exponent, needs to match r in my combination, and n comes from the total. Okay, this is going to need some simplification. I already know 11C4 is 330. I know that's x to the 7th, and -2 to the 4th power is 16. Remember your parentheses. 330 times 16 is 5,280. So 5,280 x to the 7th is the final answer for that term. So that is the 5th term. Okay, last problem. I'm sort of condensing this. Well, we're just going to do A because I think A is harder than B, so I think you'll get it after A. Okay, so 2x plus 3 to the 3rd. Okay, so the reason we need to do this is because we need to figure out how to treat something like 2x. It's not just x, it's 2x. So it's very important that we're very careful. Okay, and when I say expand, I mean write out the whole thing. We're not just finding one of the terms, we're going to find all of the terms. And in this case, it says use Pascal's triangle. Notice we have a 3 here, so that's an easier one. We don't need to use combinations. Okay, so I'm going to go to row 3, 1, 3, 3, 1. I'm going to write row 3 is 1, 3, 3, 1 off to the side here, so I can use that. Okay. Notice that's a cubed, so there will be 4 terms in the end. Okay, so the first we'll have a 1 as our leading coefficient here, and then same principle applies. You take the thing in the front of the parentheses, but make sure to put it in parentheses here because you have 2x, not just x, to the full power. And then the thing in the back of the parentheses will have the 0 power. And you can see how I'm going to progress. This one's going to go down a power each time. This one's going to go up a power each time. Plus 3, so I'm here, second one in. 2x goes down a power, 3 goes up a power. 3, 2x goes down a power, 3 goes up a power. Plus 1, 2x goes down a power, 3 goes up a power. Okay, now making sure that you see this in parentheses, 2x cubed is not 2x cubed. You have to cube both things. So this is 8x cubed. The 1 and the 3 to the 0 are both 1s, so those go away. Plus, okay, so this is 3 times 2x squared is 4x squared. You need to square that, and times 3 plus 3, 2x to the 1 is 2x, 3 squared is 9, plus 1, 2x to the 0 is 1, 3 to the 3rd is, 27. Oh, look who it is. I brought my white out. You're all good. Okay, 27. Okay, so now I just need to clean this up a little bit to make it look like a polynomial. So 8x to the 3rd plus, okay, so I have 3 times 4 is 12 times 3 is 36 plus 3 times 2 is 6 times 9 is 54 plus 27, and that is the final answer. Okay, everybody, thanks for that. I know it was kind of long, but hopefully it was really helpful, and I'll talk to you guys soon.